Okay, so my capstone project is on the improving ex-ovo culturing systems. So to start off with, I'm going to explain what ex-ovo culture systems are. Oftentimes people, if I say ex-ovo culturing or ex-ovo culturing systems, have no idea what that entails. So first we're going to talk about that. Um, what does it even mean? So ex-ovo culturing that I'm looking into is pretty much simply stated hatching a chick without an eggshell. This is often done by placing it in a cup that has a plastic sling in it and then cracking the egg into the cup, into the plastic sling. As you can see here, there is what looks like a normal egg that we'd crack open. Maybe you'd eat it for breakfast or something. And then inside B, you can see a further development. You can see right here what perhaps might be an eye, even, along with blood vessels and things that are contriving nutrients from the egg yolks. And then in C, I think this is really cool. You can tell, obviously, the shape of this little chick, and it's very complex system of blood vessels that surround it. So that's a little bit of basic information about ex-ovo culturing. You can do it with turtles and other reptiles outside of the eggshell, but my project primarily stems around chick embryos and the development of that. Let me move myself over here. Why does it matter? Like, why are we interested at all in ex-ovo culturing systems? So the reason that I'm studying this is that the embryonic development of chicks actually provides insight to a plethora of topics in science. The most interesting ones for me are gene manipulation. What happens if I take the DNA of a cell and I tweak the DNA? How does that DNA being tweaked affect the development of the overall chick? Some other really cool ones: microsurgery, the effects of tiny microscopic surgeries that take place and the influences of them. Understanding tumor biology, regenerative medicines, even cell tracking and cell transplantation, which primarily have to do with either the extraction of stem cell and implanting it into a certain developing part of the body to see if it indeed does become other blood cells or bone or muscle or nerve cells even. What this one is a picture of, however, is angiogenesis. Angiogenesis is blood vessels, the growth of blood vessels. As you can see in the slide just one before this one. This one is an artistic description, though, of what that might look like on a cellular level. The history of ex-ovo culturing has actually a long before ex-ovo culturing systems were even created. They started with the shell, just a regular egg that you'd get from a chicken that laid it, and they would cut a piece of the shell away to allow a window of visibility into the developing embryo. This technique is called windowing for that reason. It provided a lot of insight. However, the visibility was really restricted due to the little hole and the rest of the embryo surrounded by the opaque shell. The next thing that was done to try to view these chick developments was the process of a surrogate shell, which is extremely similar to windowing. The only difference is that you take the embryo from the chick egg, say, and you place it within a larger eggshell, say a duck, or in extreme cases maybe an ostrich, although that probably wouldn't provide the necessary covering and insulation from it. I guess it could be done. These were also really good first steps in being able to see embryonic development. However, we have developed now a system that without any shell at all, as we kind of talked about, and that is the current Ex-Ovo culturing systems that they place with even plastic cups and cover it so that they don't dry out. And what's incredible about eggs is that can happen. You can take them out of their shell, and with the albumin and the yolk, the egg has all the nutrients it needs to develop fully. That's one of the advantages of Ex-Ovo culturing. But there's also a completely unobstructed view of development when you have the embryo out of the eggshell. You can see 360 degrees in every direction. There's no necessities of complex instruments. This allows for day-to-day observation with the naked eye. It's extremely cost-effective. If you can imagine, an egg doesn't cost too much, and neither does plastic cup or some plastic to put it in. And it's totally non-invasive. You don't have to obstruct or bother the albumin or the yolk within the plastic sling, and you can let it develop normally. There are disadvantages, like everything. As there are advantages, there are also disadvantages. Disadvantages include primarily they come from the lack of the shell. The shell is actually part of that beginning embryo, and when that is stripped away, the functionality of it is actually felt throughout that embryo. An eggshell is oxygen and gas permeable, which means that gases, especially carbon dioxide and oxygen, are able to pass through the eggshell. So as the chicken embryo develops, there's going to be carbon dioxide that is going to have to be released, and oxygen, fresh oxygen that will need to be taken in, and that is facilitated often in nature by the egg shell. But without that, oxygen can't reach the embryo. There are also nutrients lost from the eggshell itself, calcium being the key one, but also magnesium, copper, and phosphorus that are crucial in very fine, delicate processes of embryo development. And because of these losses, the hatchability, so the amount of chicks that hatch when the embryo is placed in these Ex-Ovo culture systems, is often less than 25%, which is incredibly low. And the viability or the survival rate of even those are very low as well. So our hope is to create a system. So sorry, I foolishly placed this. A solution that maintains the advantages of a simple Ex-Ovo culturing system, while also creating the ability for oxygen to go in and out freely, and hopes to ratify that problem of oxygen not being present. That's the best way to say that. So you can see here on the left a very crude, basic Ex-Ovo culture system. You might see that in elementary schools for the very beginnings of what development and the blood vessels start looking like. On the right over here, however, we have a very complex biochemical engineered transparent eggshell. It's really remarkable in its properties. However, it is extremely expensive to create and manufacture. So we're hoping to kind of combine these two in creating a cost-effective, non-invasive, observable system in which the embryonic chicks can grow. Looking further, even after that, once the oxygen part is kind of tackled and been able to be overcome, I guess, the next one would be addressing the minerals and the mineral deficiency that comes from the loss of the shell. So the copper, the calcium, the phosphorus, and the magnesium are still not present when oxygen is allowed to come in and out. And that would be the next step in investigation once the oxygen problem is surmounted. And this is my works cited. I hope you learned something, and I hope you look at eggs a little bit differently from now on. Thank you.